All right. Welcome to Corporate Coder. This is the show where I code things and I explain what I'm doing along the way. So if you might notice, if you're very, observative, there's a new webcam down here. So I had two webcams, so I figured why not. So I moved my face one to my laptop. And then I moved my other one over to my bird feeder. Anytime in the other streams where you saw me looking off to the left out the window, it's usually me looking at birds or squirrels or something. So I figured that could be entertaining. Let's see. So let's see what we had planned for today. So go into Nuthatch, go into Corporate Coder Nuthatch. Let's open the Atom here. Thank you, Adam. Oh, I know what it was. So I wanted to do a demo, which is with an animation. Let me create a new demo here. Sprite sheet animation. So basically, I wanted to show how to use this library to do animations using sprite sheets. So let's start npm run dev. Let's get the TypeScript compiling going. I have a different webcam characteristic down here. So I know the webcam is within here. I have a little box here set up so I can see it. Okay, let's get a new tab going. I see there are TypeScript errors from last time I didn't fix. Corporate Coder, Nuthatch. Let's get the test going. Oh yeah, so if you're new to the stream, what we're working on is Nuthatch is a set of game tools. It's kind of like a game engine, but it's a little bit more freeform than that. If you go to my Patreon page, patreon.com/DannyFritz, you can see GitHub/Corporate Coder. You can also get to previous streams on the YouTube channel or the live stream on Twitch. And if you go to Nuthatch, you can see what we're working on. So we're working on day 19 today. Day 18 was yesterday. So I want to create a new demo here. Well, actually, before I do anything, I should probably fix these compiler errors. So it's cannot find color, cannot find color, cannot find color, cannot find color. Okay. So I think these are all inside of graphics. Yeah. So I probably just didn't import color. It's easy enough. So I moved vector 2 last time, or I moved color to vector 2 or vector last time. So I need to import color. And that took us down from 7 to 1. Okay. So let's see. I guess it's not going to show us the other ones. I'm not really sure what's going on here. I'm really curious what these other ones enter. Let's see if the compiler tells us. Oh, no, so there's nothing else. Okay. So this linter is just full of crap. Whoa. I'm just going to ignore that for now. So, fix that. Let's go into our tests. Let's go into our demos. Let's just copy Pong. Let's call it Sprite animation. And we're not going to need so many things. We probably just need the game. Let's see. So Nuthatch demo. Sprite animation. We're going to call it, sure, game, why not? We want the runtime, we want the graphics. I don't care about the keyboard, ball, or paddle. So it's great, I don't care about these. I don't care about these. I don't care about these. All right. So we have our basic runtime going. I need to add it to this page now. I called it Sprite animation. Okay, so here we go. I can't call it game in my mind. I'm going to call it main. So we're not making a game here. Okay. So we need to load an image. I need to go find an image, that means. So the duck one we had before wasn't very good for animations. So let's go find, let's see if the metals rotate. No. Explosion. It's hard to tell what these are supposed to be doing. It's the preview. You're supposed to combine them. How about, no. Tappy plane? Do you have obvious animations? You do. The propeller spins, kind of. Kind of goofy. Tower defense. What do your animations look like? Because they don't have animations. Let's go to another Kenny game assets. Maybe number 3 has good animations. Number 2. Fish. Do you guys animate? I don't think so. Sci-fi? I guess these packs are just not all that much about animation. I might just go back to airplane. Airplane just might have to do. Ooh, those look like animations. Okay, so an animation might be, oh boy, it's hard to tell. I guess that's what the XMLs are for with it. They tell you the order of the animation. I think just play around with this. This should work. I think I can just copy it to here. Cool. No. Do that. No, bring it back. Bring it back. Is there no undo? Okay. Open Explorer. Copy. Okay. So basically, we're going to want to find 2 of these sprites and then animate between them. I think. Oh, there's a thing there. I think right off the bat, I'm just going to want to go open this in GIMP, I think. Because of that way, I can get the dimensions really easily. Okay. So first thing I want to do is I actually just want to draw something on here. So we're going to say const sprite sheet equals new image, sprite sheet dot source equals sokoban sprite sheet at 2.png. And then we're going to say if sprite sheet dot, oh, what is it? Done, complete. We're going to say graphics.image sprite sheet. And then we'll see where we're at. Okay, did it load in the image? That's the first thing I want to check. It did load in the image. Sprite sheet.complete never happened though. So console.log sprite sheet.complete. True. Graphics.image. Oh, I need to set the graphics.set transformation matrix. It's going to become matrix dot orthogonal 300 300. Okay, so matrix dot orthogonal is not a function. Really? Oh, wait. Orthographic. Orthographic. Set transformation matrix to transform matrix. Okay, there we go. There's our image. So now I want to draw just one sprite of that. So I believe that's sprite, and there are two things to it. Oops. There's a position and a size. And the position would be our first one. Let's have him walk to the right. So is there a standing one? This one here. So let's copy this out. Man, these are tightly packed. I don't really know what the width is supposed to be. Probably not this big. We'll figure it out as we go. So it is 1086, 880. And then it is 114 and then 100. So 100 by 100 would make a lot more sense. I'm just going to go with that. Okay, there we go. So we got that guy. So then our next sprite is, so if that's the standing guy, what does first step look like? What options do I have? I have that one, I have that one. It's hand moved. Okay, so there are 1, 2, 3. So we're between these two. Oh, there's an outline. There's no outline here. Is that the only difference? So the ones without the outline then. So the ones without the outline are just down here. Okay. So there's a standing one, there's a walking one, and there's a second walking one. So I don't entirely know how we're supposed to be configuring these together. Imagine the hand follows second. So we want this one next. So in this one, let's see what we got. 986, 1096, and then interesting, 91 by 100. Oh. Okay, so now we got them both there. So we have a third and fourth one that we're going to do. So next, I think, is this one. So I'm just gonna, oops, no, I'm just gonna highlight him also. Okay, so the position is 1076, 1096. So it's pretty similar to this. And then I'm going to keep those the same. Okay, and then one more, right? Oh no, that's it. Yeah, that's it. Okay, so we have our three sprites. We want to animate between these three. So if I comment out this one, comment out this one, it looks like that. And then if I comment out this one, uncomment out this one, it looks like that, right? So basically I want code that does this, comments out, uncomments one of these at a time. So I'm actually going to, outside of here, create frames. I'm going to pull these all up there for now. So these are the three frames that I want. Keep losing my OpenGL context. I think my images are so inefficient right now that it's kind of crashing after a bit. That's okay for now. Unindent them over time. Okay, so graphics.sprite I can't be called here. It needs to be something like graphics.sprite sprite sheet, and then something needs to happen here. Something like, I'll work it out. So let's cannibalize these lines. Let's undent it. I wonder if it should look like this. So basically, I have an array of arrays with objects in them. And I'm going to take one out every single time. So if I do frames of 0, so I got that one. And if I do frames of 1, I got the next one. If I do frames of 2, I get even the next one. Okay. So we want to animate this. Let me look. I think I have a method on runtime I can call like at the current time. I also want to get rid of this console log. And then we'll probably want to do something about the GPU. And the CPU, I guess. I mean, this is a little bit ridiculous, right? Oh, wow, I didn't know there were all these choices. Yeah, my WebGL just crashed. I'm assuming I'm running out of texture memory. I don't know what these things are. Why are there two video decodes? Why are they different? So yeah, so here's where it crashed. It's not running out of memory. So, where was that? So I'll get this animation working, and then we're going to optimize our images. Oh yeah, I was looking at runtime. So runtime, I believe, is a way to get the time elapsed. So I can use time elapsed here for this. So let's say instead of 2, it's going to be runtime.time elapsed. Was that a getter? No. Mod 2. So there's only frames length. So now it's going to flash around really fast, or not at all. Undefined is non-iterable. Let's see, 0, 1, 2. Frames length is 3, -1. Frames, time elapsed. Time elapsed. Line 34. Maybe it's not iterable. All right. I'm going to see what it looks like. Number 3, that's fine. -1. 2, that's fine. Runtime.time elapsed. Mod by that. That's all right. Math.floor. All right. Okay. So now he's walking as quick as he can. Let's slow this down. So time elapsed. I don't want to go so fast. So in order to stretch out something, I want to divide this by like 100, let's say. I want to go 100 times slower. No. So it's probably pretty decent. Let's check down here though. I'm gonna run. Let him go. Let's slow it down even more. I want to take a look at this. We're missing a frame. Right? Where's he's supposed to have his legs out and his arm forward. Okay, so we need to do const frame equals that. Console.log frame, frames of frame. Let's reload WebGL. 0, 1, ooh. I don't want the -1. Okay. I wonder if there's one more frame that I want. Answer to that is no. There's no more frames I want. Okay. So I'm assuming that's the walking animation that is implied. All right. So let's go fix the bug for images. So I think we want to detect if we pass in the same image and then just don't rebind that or reuse that texture object. So originally I was kind of thinking that I wanted to create like an image object that we pass back to the user and have them manage, but I'd rather if it was transparent where internally I'm going to keep track of these things. So I want a weak map. So once again, because we're living in the future with this thing, although it has really good support, what a weak map does is, I guess we should talk about JavaScript garbage collection so we can talk about weak map. So if I plug in my tablet, and let's open up OneNote. Let's create a new day. Let's call it day 19. Week map. What was yesterday? I should probably label these. Okay, so week map and Sprite animation. So let's turn on our drawing. Oh, today they fixed this since the last time I used it. Oh, that's really cool. There used to be a stupid button here I had to click, but now it just kind of works. What about with like, I can't even draw with my finger. Okay, so JavaScript, let me write a little bit neater, is a garbage, I should really write not is a, has a garbage collector. Oh boy. Or a GC. So when you're looking at performance panel in JavaScript, you see GC or anything like that, GC main, GC minor, or major, I mean. It's talking about the garbage collector. And what that means really is that it has a runtime. It's really going to do this for managing memory automatically. So there are some features coming out, but largely you have no control when this runs. You have no control when a garbage collection happens. It just happens, and it might cause jank. You might lose a frame or two because of it. And there's nothing you can really do about it other than just don't cause garbage. Chrome and Firefox and Edge, all these browsers are working really, really hard to make these as painless as possible. Chrome is pulling out as much as it can into a separate thread, so it doesn't matter. It just does it in the background. But for now, you have to worry about it. So basically, C, Rust, C++ have no garbage collector. So you manage memory. In C and C++, that means you have to call mallocs and freeze. You have to do constructors and destructors, things like that, because if you don't, your computer will just never delete that memory, and then you'll just hang on to it forever. Doesn't matter what it is, as long as it's in the heap. If it's in the stack, it's okay. So JavaScript has a runtime. You can't run JavaScript without having a JavaScript runtime. Wish I knew what was stopping it from drawing. So C, Rust, C++ has a target. So there's no runtime for these. You can sometimes kind of argue there's runtimes depending on what your target is, but when it comes down to it, your target is a machine. So on this computer, I'm running x64. So look at dxdiag. Let's see what kind of information it gives me. Doesn't say my instruction set, but I have an Intel Core i7, which is a pretty standard x64 machine. So x64 are the instructions that my software on my computer more or less can give to my CPU, and it'll run those things. It's things like add integers, add floats, move data to memory, read memory, 2 registers. There's tons and tons of things like that. They're very, very low-level things. It's never like open a window or show a letter on the screen. It's much, much lower level than that. But C and C++ and Rust, they all compile to one of those, and there's no runtime on your CPU. If you write something to your memory and you don't come back and clean it up, like that's what your software does in these. In JavaScript, when you write to memory and then you're done with something, like you're relying on JavaScript to go and find it and clean it up. So how does that work? So let's look at this code. Var A equals a new object. Var B equals a new object. So already JavaScript is looking through here. It comes to here, and there's a heap, and it says, oh, hey, I need a place to store this. So it takes that and it puts it there. And it's like, oh, I need a place to store that too, and puts it there. So there's 2 places for these things, and then a bunch of code happens, let's say. And then later on you say A equals B. And now, look, B or A points to there. And then there's no longer this, right? So at some point in time, you're going to have a heap that looks like this. There's just tons and tons and tons of objects and data in here. You know, functions, variables, strings, just all hanging onto your memory. And your garbage collector is going to come in here. And he's going to look at, you know, it says find references. Just comes in there and we'll look at each reference. Let's say it's looking at this one. 2. Does anyone, or not find references really, but find memory allocations. Find allocations. Oops. Does anyone reference this? So ask that question. When it's looking at this, it says, are there any arrows, like purple arrows? Is there a purple arrow pointing at this? And the answer is no. So the garbage collector is going to delete. If no references. So let's do a little key real quick. Reference. Object allocated. All right, so it's going to look at that and it's going to be like, nope, we're going to clear that out. So X's that out. And then it's going to move on to the next one and be like, okay, oops. It's like, does this one have anything? And it's going to be like, nope. And it's going to look at the next one and it's going to be like, does this one have anything? It's going to be like, nope. And then maybe it's going to go down finally and look at like one like this. And it's like, does it have anything? And the answer is yes. So it leaves it alone, right? And it just moves on. So this is doing all of your frees. It's freeing your memory. And these are doing your mallocs. It's creating places in memory for you to store things. So when you do that, it's a malloc. When you do that, it's a malloc. When the garbage collector does that, it's a free. And you don't have to manage that. You just get to assume that JavaScript's going to handle it. So this can be a pretty intensive process depending on how the browser implements it. You know, I don't entirely, oh yeah, this is why I'm talking about this. So if anything has a reference, it's going to have this purple arrow pointing over to it. And the garbage collector will look at those purple arrows to see if they exist or not. If they don't, it will delete it. So what is a weak map? Well, a weak map, let's say var a equals a new weak map. And a weak map is an object. So it's kind of like an object. But anytime you insert something into it, so here's our heap. Let's say we have a var b equals an object, right? And the object gets put over here. And let's say we said, I don't know how weak maps work. I'm just going to assume it's push. I could be wrong here. I'm going to push B into A. It could be a dictionary. I really don't know how it works. Actually, it probably is a dictionary. I'm going to look it up. That's fair enough. Weak map. Okay. So you say new weak map. All right. Set. So set is how you do it. Okay. So we're going to say a dot set. Let me see. How do I get this to? I don't know why this turns into a text cursor every once in a while. Is it one of these buttons? Well, that button certainly did it. Am I hitting that button? Oh, so a dot set. We're just going to set b. Why not? To b. Set b to b. But you would think that this weak map that has b in it now would have a reference that points to that. So then later I say b equals null. So then we'll remove this reference, right? B no longer points to it. But I said in the weak map, I said there's b in there, right? So that's going to point to it. So when the GC comes by and it's like looking at that, it's going to say, are there any references? It'll say yes. But the weak part of this says that it's not a true reference. It's actually just kind of like a dotted line. And it says to the GC, if there's a dotted line over to it and nothing else, you can go ahead and delete it. So it'll delete it from my weak map as soon as there are no other references to it. The reason why I want to use a weak map here is if the user is passing in an image, I'm going to cache it. But if the user deletes the image on their side, I'm not going to hold on to it and ruin their memory. It will just immediately remove it. The garbage collector will remove it when it runs. So I'm not going to hold on to the memory and cause memory leaks. So that's why I'm going to use a weak map. So the garbage collector can still collect it. So I'm just kind of curious, like what happens when, let's see. Like if I deleted O2. Oh, so, okay, so here it's showing it adds O1 to it. And it says, does I have an O1? And it's like, yes, I have an O1. Oh, what? Oh, value community. Okay. So I can do O1, O1. And then later it says, delete O1. No, that's not what I want to see. Let me make sure this does anything. It's a collection of key value pairs in which the keys are weakly referenced. The keys must be objects and the values can be arbitrary values. The keys must be objects. Why? An experienced JavaScript programmer will notice that this API could be implemented in JavaScript with two arrays, one for keys, one for values, shared by the four API methods. Such an implementation would have two inconveniences. The first one is an ON search, n being the number of keys in the map. The second one is a memory leak issue. With manually written maps, the array of keys will keep references to key objects, preventing them from being garbage collected. In native weak maps, references to key objects are held weakly, which means that they do not prevent garbage collection in the case there would be no other reference to the object. Because of the references being weak, weak map keys are not enumerable. There is no method. Okay. So you use the object as a key, and I guess I can set it to true or false. Or even undefined. Undefined sounds like a bad idea. I almost wonder if I want to do stuff like O101. Or if I'm not understanding this correctly. Weak set? I don't think weak set's what I want. Oh, maybe. Oh no, weak map is what I want. The reason being is the left side will be the image object, the right side will be the texture object. Okay, so I can always get the texture object out. All right. So we're going to do a private. We're going to do a texture cache. And it's going to be a weak map. I think. Okay, yeah. So I have to specify it from K to V. Okay, so it goes from a image, HTML image element to a WebGL texture. Source WebGL texture. Okay. And it's going to start as a new weak map. Okay. So I have a texture cache now. So we go into my images. I'm going to have one called get texture. And it's going to take in a image object. Okay, so, or my texture thing. So here's my texture thing. Oh boy. Should probably just pull this all out. Put it in here for now. Set texture maybe is a better name for it then. Let's see, an image. Image is used here. So we're going to say this dot set texture. We're going to pass in the image. And then we're going to do the same thing down here. So all this and change it to this dot set texture. Set it to the image. So I can get rid of these questions now. I'm implementing them now. I can get rid of that. Okay. Anything else image related going on here? I don't think so. Okay. So does it still work? Yes. Okay. So I didn't break that aspect of it. So now I just want to cache these textures that already exist. So this dot texture cache dot has image. So if it doesn't have it, what are we going to do? We're going to say this dot texture cache dot set image to I'm not ready to do these sorts of optimizations. I only ever want to do this once. Instead of per image. Well, we'll try it out per image for now. So I create an image or texture. I bind texture 0. I bind it to my texture. I bind some other things to it. I set a uniform, and then I upload it. I feel like this is the expensive part. Not this. We'll see. We'll see what happens. So let texture equals this dot texture cache dot get image. If there is no texture, texture equals gl dot create. Then we're going to set it to that, and then we're going to use it. Okay, let's see where we're at. Okay, it still works. Let's go see our memory usage. Let's actually put it into hyperspeed. I mean, this part's really, really slow, because we're still every single time uploading an image to the GPU. We'll do a temporary cache for now, so. Well, actually, I'll write the to-do somewhere else, but it's going to be private last texture used. It's going to be a web. It's going to be an HTML image element, I think. If last if it's the same as the image object, then return, don't do anything. Else come through here and then say this.last texture used is this one. Okay. So I wonder if it's bailing out yet. Oops. So let's see if it's bailing. Oh yeah, it's definitely bailing. Okay. This should actually happen up here. Okay. So I fixed the memory leak. Let's have it go in hyperspeed, see for sure if I fix the memory leak. Let's go to the console log. Okay. No, it definitely looks like we fixed the memory leak, right? Kind of wish there was a little bit more precision to this, but that'll work. Yep. Okay. Slow this down again. So here's a really simple way to do animations using a Sprite sheet. You just have your frames, and then you just switch between them when you're doing a Sprite sheet. There's a running little guy. One of the frames looks like it's off by 1 pixel. I mean, I'll just play around with it and see which one it is. No, it was that one. Okay. So now he's staying still, but running. My memory is staying in place, which is good. Let's do a performance test and see what we get. It's really good. So our JavaScript heap is ever increasing. We're getting 60 frames a second, or no, getting really good frames. Let's look at this one. This looks particularly larger. Okay. So it's an animation frame, a function call. What function calls this? So this GPU frame took 10 milliseconds. I'd like to see what the GPU memory is doing. I guess it doesn't know. Okay. Let's see, did it ever garbage collect? It did, so here's a garbage collection. Let's take a look at that. It's weird that it doesn't show up as a garbage collection, unless I'm missing something. Oh, minor garbage collection. So it did happen right in the middle of my function, which is kind of funny. And at the end of it, you see the memory just plummeted. So what function is this? It's runtime line 17, it's the draw call. Wait, it's literally this empty draw call? Wait a second here. No, it's not that. Okay, so the minor garbage collection happens, and then it moves on. What is this? What is this? I can't even click it, it's so small. What is this? Quest animation frame. Runtime limit 24. No, it's just off. So that a tick happens, which is line 18. And then that is a request animation frame. What's this? And then it updates the layout tree. Okay. Pause it. Here, this one looks more interesting. So it runs my draw call, which is this one. Then it runs the clear, which runs the clear color, and then it does the sprite, which is buffered data. So which buffered data is this? It's not going to let me know. Probably these, right? I mean, these do change. I wonder... I mean, these never change. Wonder if I should make this buffer in memory and then just leave it, and I can reference it when I need to. I can just bind it when I need to. I don't need to actually buffer any data into it because it's already there. I'll write that as a question for now. This buffer seems to be the next slowest thing I have. I don't really need to optimize right now. So I'm going to copy that over to Sprite 2. Well, I guess a lot of that can be, copied and pasted out into a function. This one up here can't be cached because this does change. All these things change. I have to calculate them. Unless I can take this buffer and put it in the weak map. That'd be worth looking at. Nothing too particularly interesting is going on here. I mean, this is talking about 0.15 milliseconds for like these, and then this is happening in 60 or 0.7 milliseconds. It's only spending 62 microseconds of my time though. 99 microseconds. 0.12 milliseconds. Why are these green? Clear. I don't know. And this one's orange. This one's in the library, or in the platform. Let's see, this is a bigger frame. Oh, what happened here? I don't know if I like minimized the page or something. The profiler might have kicked in. It also decided to just create a bunch of memory here, apparently. Timer fired. Oh, browser sync kicked in. Yeah, browser sync's taking up all my memory. Oh, this one's me. I did this. I don't know what I did though. Is it all these RAF IDs? It's a number though, so it should be okay. Oh. Good enough. This is the demo I wanted to get to, just showing off how to do an animation. So if anyone has any questions if they're watching, go ahead and put them in the chat. I'll see them as I set up my Git. No. So we need to modify this to do, because we did do this. I also want to do a transformation animation, or maybe I should call it a lerp, a translation lerp. So tomorrow me can know what I'm talking about. Linear interpolation. Okay, so what else? That's good. I always like it when there are either more or as many deletes as there are adds, while keeping the functionality. It's good. Demo is good. That's good. What's this? No, it's a thing I just wrote. Oh no, I don't want these. And then the image. Stay in 18. Commit. And push. All right. So without questions, I'll go ahead and end the stream. I was hoping some birds would fly into the bird feeder. I don't know why they're not there. Oh, there they are. Oh, you can't see it. Maybe you saw it flying. But I'll be in Michigan for the next week. So if I stream or not, it will be off schedule and just bonus. It won't be anything normal like what I've been doing for the last couple of weeks. So, yep. As always, the stream is a lot of fun. I'm always kind of amazed at how easy it is for me to do things that, like 5-10 years ago I thought were like impossibly hard to do. Just the fact that I can do this in my engine in a very idiomatic way is pleasing to me. I fixed memory leak. I talked about garbage collection. All sorts of good things this episode. If you like this episode and you're watching on YouTube, click like or subscribe. And if you're on Twitch, go ahead and click follow. And as always, if you go to my Patreon page, you'll get links to all of the things for this. So the YouTube channel, the Twitch channel, the GitHub for it. Yep. I'll see you later.